Hi, this is on wave propagation. This is for the FE exam, prep for electromagnetics. An electromagnetic wave is created by a local disturbance in the elements and magnetic fields. From its origin, the wave will propagate outwards in all directions if the medium in which it is propagating, air for example, is the same everywhere. The wave will spread out uniformly in all directions. Electromagnetic waves' basic properties. Speed. The speed a radio wave travels is the speed of light. Wavelength is the distance between a given point on one cycle and the same point on the next new cycle. Frequency is the number of times a particular point on the wave moves up and down in a given amount of time. Wavelengths used to be the way to measure signals, but now frequency is the way of measuring it as it is more precise. Electromagnetic waves are affected by the media they travel through. Signals can be reflected, refracted, diffracted, or absorbed. Reflection. Reflection is when a plane wave encounters a change in medium. Some or all of it may propagate into the new medium or be reflected from it. The part that enters the new medium is called the transmitted portion, and the other the reflected portion. The angle of reflection equals the angle of incidence. Reflection involves a change in direction of waves when they bounce off a barrier. Refraction. Refraction of waves involves a change in direction of waves as they pass from one medium to another. Refraction, or the bending of the path of waves, is accompanied by a change in speed and wavelength of the waves. The angle of incidence by the angle of refraction are linked by Snell's law that states N1 sine theta 1 equals N2 sine theta 2. And here you have a picture of how it works. You put a pencil in a glass of water, and the pencil looks like it's actually broken or moved. That's what we're talking about when we speak of refraction. Diffraction is found when a signal encounters an obstacle. They tend to travel around the obstacle. So here's an illustration using a wave. As the wave goes through the gap, it spreads out. That's the one on the left. And then on the right, the same thing happens as it goes around the obstacle. So it's almost like it builds back up. So, quick summary. Reflection, refraction, and diffraction are all boundary behaviors of waves associated with the bending of the path of a wave. The bending of the path is an observable behavior when the medium is a 2- or 3-dimensional medium. Reflection occurs when there is bouncing off of a barrier. Reflection of waves of straight barriers follow the law of reflection. Reflection of waves off parabolic barriers results in the convergences of waves at focal point. Refraction is the change in direction of waves that occurs when waves travel from one medium to another. Refraction is always accompanied by a wavelength and speed change. Diffraction is the bending of waves around obstacles and openings. The amount of diffraction increases with its increasing wavelength. Here you see the wave equation followed by Poynting's theorem. Rate of energy transferred to distant points by electric and magnetic field intensities. So you have the integral of E times H ds equals the negative integral of J times E plus the time rate of change, the integral to times half of epsilon E squared plus mu H squared. So the vector quantity inside the first integral, E times H, is known as Poynting times vector P. Some books use S, and it is the power